Hi Leonardo, I promised you this video. This is something that I think you should explain in one of the video. Maybe you do this video before double integral. So this is the idea that I want you to make it clear. So imagine that you have a function here. The value of the function, according to what I wrote, is f of xy, and is this height, the value of the function. So you have to imagine that there is a function here. So what happens if I decide to find the area that exists at the position y equal y0? So I will do like it's not exactly a rectangle, because the function can do something like this, okay? I don't know. So, but you imagine the function on the top. So, what is the area that exists at the position y equal y0? So you make stripes like this, and the area will be f of x comma y0, this f of x, this x. Let's go to put it here, the x, this x. F of x comma y0 multiplied by the height, so multiplied by the width. The width is ddx. So it's clear that the area at y equal y0 is the integral from x1 to x2 of the function f of x comma y0 ddx. Let's go to write this equation, this formula, as any point y that you find. So the area of this rectangle with the height is the value of the function, the area at any position y, that you imagine, is the integral from x1 to x2 of f of xy ddx. Okay, this is the area. This is the area that exists at the position y. Now I need to perform an integral. I need to find the volume. So let's say that now the function is doing like this. Okay, so I need to find this volume, this small volume. The small volume that is here, ddv, is the value of the area a of x comma y0, the area that exists at the position y, x of xy, multiplied by ddy, this ddy. So this volume, or the small volume, is a of y multiplied by ddy, and the total volume is the integral of a of y by ddy. But because a of y is the integral from x1 to x2 of f of xy, comma ddx, this is a of y, and the integral from y1 to y2 of this expression ddy, this is the total volume that you are calculating. Let's go to do it in the opposite order. The order here is ddx, ddy, and you see in the region, in the R region, in the plane xy, the stripes looks like this, and you are moving the stripe in this direction. Okay, let's go to do it in the opposite order, dy dx. So the picture would be like this. So for this picture, the order is ddx, ddy. Let's go to see in the opposite order how it will look the picture in the plane xy. Of course, here there is the function that we are calculating. Now, the picture is the one that I draw here. Now, the area that exists at the position x0 is the integral of f of x0 dy. So I'm summing all these, the value of the function, and I'm summing in the y direction. And now I want to find the area at any generic position x will be this expression. And what will be the volume? If I move in the x direction, ddx, I generated a small volume. You see the small volume, right? You see the small volume that is here, ddv. So ddv will be the integral of the area that exists at the position x by ddx. So what will be the volume? The volume will be the sum of all the small volume when I move in the direction. So the total volume is the sum of all the small volume ddv sub p. So this is 1 ddv sub p. This one is 1 of ddv sub p. When I'm moving in the x direction, I'm covering the whole volume. And one of small volume is the area that exists at the position x by ddx. But the area that exists at the position x is all this expression. So the total volume will be the integral from x1 to x2 of what? Of the area AX, the area AX by ddx. So this is the total integral. As you see in the plane xy, the stripe that you see is something like this. It's moving in the x direction. So you are calculating the area first, the area that exists in the position x, this area. And the area that exists at the position x is the integral in the y direction, is the integral of f of x comma y dy. Later on, if you want to find the volume, you are calculating a of x ddx, and this is the small volume, and the total volume is the integral of a of x ddx, or in other words, the total volume will be the integral from x1 to x2 of a of x. A of x is the integral from y1 to y2 of f of x comma y dy, and now this ddx is here. This is the idea.